Welcome everybody. Question 4 is about circuit. 4a is a very innovative question. It talks about current rules, right? Flow in equals flow out, the junction rule. But it talks about where does it come from? What's the fundamental law behind it? The concept is charge flow in must flow out. Okay, it means that charge cannot be created or destroyed. Charge is conserved. So it is a conservation of charge is the fundamental law behind it. Really, conservation of charge. Next is a more normal one. It is a real cell. Okay, it has a EMF, internal resistance, and it is connected to an external resistor 5 ohm. And then it said that voltmeter reading is 1.2. Remember to write it in the diagram. So this is a 1.20 voltage. After writing down, you notice the difference, right? 1.5 and 1.2. Where does the rest 0.30 voltage go to? Internal resistor. So in the internal resistor in this scenario, dissipates 0.3 volts. Determine the internal resistance of the cell. So look at the circuit. One loop, right? So the internal resistor and the resistor share the voltage proportional to their resistance. So we have the equation here. Okay, so R over 5.00. Remember, write down according to the least accuracy equals dissipated voltage by the internal resistor and dissipated by the external resistor. Now it's your turn. Calculate it. How many ohms? Yes, you got it. Well done. 1.25 ohms. Okay, so R equals 1.25 ohm. Well done. How about the second part? The second part is a qualitative discussion. You said that we add one more resistor here and low calculation. Okay, what will happen to the voltmeter reading? Increase, decrease, or remains unchanged. So look at here first. So you notice that adding in parallel resistor. So the external circuit or the external total resistance will rise or drop. Parallel, yeah, so it will drop. Okay, so it will the external resistor, okay, say it will share fewer voltage, right? Fewer, yeah, because less resistance. It will share fewer voltage, so the voltmeter reading drops. That's it. We make it for question 4. Well done, guys. See you for question 5.